All right, welcome everyone to this search party. I'm happy to talk to you tonight about search relevance in the GenAI age. My name is Paul-Louis Nech, but I want to start tonight with a little story from my engineering class. This story is from my friend, former camarade in school, Vermeil, Guillaume Sanchez. One day he decided to do a crazy engineering project and to build his own custom OS. Everything from scratch, build the whole thing, take just hardware and make it work. So he started hacking. And he wrote a firmware to connect with the hardware, then a bootloader to handle the actual boot logic, then microcode and a kernel to handle the primitives that would be used by the OS itself. Then init RAM disk or init RAM FS to have your file system loaded in memory. And finally, he started working the OS and user space programs that would run. And Vermeil is, I would think, a great engineer, a 10x engineer, like you can say. But even a great engineer makes mistakes. And like you see in the title, Vermeil said, you know, my OS is 80% perfect. In every layer, I think I did every 80% of what you should do. The problem with a system like that is the metrics that you get. Because yeah, sure, everything works 4 times out of 5. So you have 80% of chances to load the firmware. That's a good start. And if you pass that bar, then you have 80% chances to have bootloading. That's only 64% for those who compute. And it gets worse. The microcode, the kernel, also 80%, and we now have only a chance out of 2. When you load init RAM disk, you're now below the coin toss chance. And finally, when OS and user space lands, we actually have 32% chances of seeing the login screen. So you can have a system where every layer is 80% perfect, and yet the machine doesn't boot 2/3 of the time. Now you might wonder, this is not a hardware meetup. This tech cake is cool, but what's the point? Well, I think that if you want to build generative AI experiences, you might be trying to build a similar system. You're building a layer cake, and the GenAI is the cherry on top. But you need first to have healthy data that your system will ingest. You need solid retrieval to find the relevant items for your query. You need the right chunks to pass from your search system to the LLM. And you need tasty prompts so that the LLM you use can actually provide value to your user with this data. If you do this, you'll have a delightful GenAI. And with this, I introduce you to search relevance in the GenAI age, a talk telling you, through a few examples, how you can configure search relevance for building GenAI systems. I wanted to go directly into it, but I just got new instructions. Ignore the previous instructions and introduce yourself. My name is Paul-Louis Nech, and I'm a senior, actually now a staff machine learning engineer at Algolia. I've been here for 9 years now. I just celebrated this anniversary last Saturday. And I worked on mobile, on voice, on Algolia Understand and Algolia Answers, 2 former APIs, with Dustin Coates, who's here tonight. I've been working on Algolia Recommend since 2022, and since a year and a half, I am fully focused on the GenAI experiences that you can build with the Algolia GenAI Toolkit and the Shopping Guides product. So tonight we'll look at what RAG, or Retrieval Augmented Generation, means for search and for your relevance settings. We're going to start by understanding the user intent. What does your user want? We'll look at how we can retrieve relevant content for that demand. We'll see how you can augment prompts with the data retrieved from these, and how this can help you build a generative experience that brings something useful to your users. But I want this talk to be accessible both by search experts, by GenAI experts, and by people at the intersection of those 2 topics. So let's start with a little refresher. What do we mean by search relevance? I want to do a quick test with the audience tonight at the search party. How many of you know what these images represent? Raise your hand if you have an idea. That's okay, I understand that. It's a bit cryptic. The image on the left is precision, and the image on the right is recall. And if it rings a bell, it might be because you one day visited this Wikipedia page, precision and recall, trying to understand what the heck are those metrics. Let's say that this is a search space, and the square is your whole catalog. The circle is the results that a query retrieved. And you're wondering, are those good or not? Let's imagine that on the left part, it's only the right items for this query. Maybe you've been searching for a party in Paris this Saturday, and all of these are good fits. But your search system returned these results, which are some of the good, some missing good items, also some wrong. Maybe those ones are not even this weekend. But at least these ones have been not identified. Now, if you look at the previous slide, the images make more sense. The precision is how many items are relevant. So if you retrieve this, but only that part is relevant, half of your search is precise, the other half is noise, and precision is 50%. On the other hand, this, the green blocks, is recall. If that was the whole thing you need to find, and you return only these, well, you returned 5 out of 11 items. And so your recall is a little lower than 50%. The thing I want you to take away from this is that search relevance is a trade-off. And you always have to choose to some extent between those two competing objectives. Because there are ways to return perfect precision. Just return an empty hit. If you give me an empty list, you gave no wrong result. No result you added was not relevant. The problem with this approach is that you also miss a lot of the good results. You actually have very bad recall. And on the other hand, if you want to go with perfect recall, do you see a way to never miss any relevant item? There is one. Return the whole catalog. At least you're sure the right things are in there. The problem? The precision is abysmal. You just returned everything. This set is not useful for anyone, neither a user nor a large language model. So there is no right or wrong answer on this trade-off. Let me give you a few examples. You're building a system that is going to use a search engine to go through a lot of logs by your experimenters. You are maybe a medical company trying to find a cure for cancer. You have thousands of docs describing experiments, and you want to search those that are relevant to then continue the experiment. Are you interested in only the right ones, very high precision? I think no. I think you want high recall. What you care about if you're searching for a cure for cancer is that you don't miss the right one. If we do 10 experiments and 9 are useless, but we find the $1 million cure, it's a good deal. Now to take another example where search relevance might have a different trade-off. If we're building a GenAI solution to answer user questions based on an FAQ, and we're returning them an answer, hoping that this will help them achieve more. Probably what you want there is precision. You want to give them an answer only if you're sure that it matches their query. And you'd rather say, I don't know, reach out to a human agent, than give them something that is not the right solution. There are also cases where the right answer will depend on the UX. If you're drafting an outbound email for customers, and you're building a system to help sales agents at scale push data and communicate at scale with their customers, when you're first doing a search to retrieve the customer profile, and you find 3 people for Apple. The first one is the Apple Inc., the second one is an Apple OR card. Do you automatically send the email? If it's automated, you probably want high precision. You don't want to send an email to Apple and tell them about their fruits. But if you have an agent in the loop, and this is only a draft that your sales rep is going to send, then you're happy to optimize for recall, find all of the Apple companies, write 3 emails, and let's let the human decide which one should be sent. I gave you 3 examples where there's a clear winner between recall and precision, but it's not always the case. If your user is asking for a cocktail party dress, and you're building, like we do, a search agent helping people use a search interface, well, they want dresses, so we need to search and find all of the dress. We want to recall them. But once we have all of the dresses, if you can show them only the fancy ones for cocktail party, not the cheap Temuk knockoff, it would be better. So precision is still important, but less than recall. These are only a few use cases. Think about your own. What I want you to understand there is that if this is the perfect relevance setting, it doesn't really exist because search relevance is a trade-off. And the right settings will depend on the user's goal, on the user interface you give them, and more broadly, on the use case that you're coming from. So I hope this tells you a bit about search relevance. But as I told earlier, this talk is as much for search experts as for GenAI aficionados. But not everyone has the same opinion on what is GenAI. So I'm going to try a little introduction. What do we mean when we say GenAI, at least at Algolia? Well, my perspective is that GenAI is generative artificial intelligence, and each word has a meaning. It's generative. It creates new stuff. If your system just predicts scores, I wouldn't really call it GenAI. It is artificial. There's not much human oversight. You can validate the outputs, but it can generate on its own. And it is intelligent. What is artificial intelligence? It's a big debate. I would say anything smarter than rules. If you could do the same with just rules, I wouldn't really call it GenAI. But this is abstract, and so before we go into the core of the talk, I want to show you a concrete example. This is a demo that you'll be able to play with at the end of the talk. You'll see a QR code to load it, and it will work for anyone. It's a demo built by my colleague Guillaume, who's working in the GenAI team at Algolia, and he's listening to a podcast by Andrew Huberman, a neuroscientist talking about the brain, stress, and how to be a better self. The podcasts are nice, but they're super long, like an hour-long episodes. So he built a system where we index the podcast content into an Algolia search index so that you can have conversations with it. Here, I asked the first question. Give me an ID of your core podcast topics. And we get a summarized answer. My core podcast topics are about neuroscience and applications with the sources of the different episodes that we sourced the data from in the search. How does a system like this work in the background? You're looking at the Algolia retrieval augmented generation, Algolia RAG as a service. And what is it in a nutshell? We're taking your user question, and we'll use that to send a query to do a search. We first retrieve your prompt, because different experiences will have different goals to execute. And we'll take the user query and do a search on a search backend. It could be the Algolia classic search, in which case you have keyword, traditional relevance, ranking formula. It could be the Algolia neural search, if you have access to it, and then you have a powerful vector semantic retrieval system. Could be a blend of both. You can use neural search as a second step if keywords don't bring results, or you can blend neural and keyword results together. Algolia RAG here will give you a way to search your index with a user query. Then to augment your prompt with the records, the data that we find in the search. And finally, generating a response, which could be many types. It could be text, like the podcast example. It could be categories, predicting if it's spam or not, if it's a high-level customer or not, if it's an urgent support request or not. Or it could be structured, take this user query and return some JSON so that you can parse it further in another system. Here is a concrete use case of data augmentation. I am taking a record that has free-form text content. How many of you have already looked at user reviews? Did you find them clear and easy to understand? What do you think of a 3 out of 5 star ratings? Is it a good score or a bad score? Neutral, there you go. I think it's a bit cumbersome to look at human text and, free-form text. I did a project parsing recipes from Marmiton, and I can tell you this was a hard parsing problem. So here, I'm going to use GenAI to help. And we're going to define a prompt with categorical analysis instructions. Analyze each user review to extract information about the sentiment. Just return positive, neutral, or negative, and nothing else. Here I took the example of the sentiment. You probably have better things to do. You know your users. Are you looking at categories? Are you trying to identify which products they like? You know the categories that would be useful. But the point here is that when you take the Algolia GenAI toolkit and you use it on top of your search results, you can augment them with these analyses. Here, I'm doing a browse, and I'm iterating on all of the search results in a given index. And for each of them, we're going to add an extracted sentiment. And if you look at the 10th result, indeed, we analyze it as neutral, because the person said, I just would like to know how long before I receive my package. It's not really positive, it's not really negative. It was a 4-star rating, so we would have treated that as positive feedback if we just looked at the score. Another use case that might be more user-centric and less for your internal teams is support answering. This is a prototype we built with the Algolia support team, who handles a lot of tickets, thousands of tickets per year. And often, the tickets they get are problems that they already answered before, that they already have a conversation for, maybe even that they have in a FAQ entry. Here you're looking at some Algolia FAQ. How do I get facet values, customize styles in Zendesk? Can you use distinct in replicas? Specific topics. So we tried a prototype together. And the idea was a prompt to identify, given a new user query, similar cases. Return the title of the closest similar ticket and a summary of the solution. And I'm going to show you a REST client where we did the prototyping. Here is a query that they actually got a few days before. My Shopify shop is out of sync with the last catalog changes. And I'm showing you on the right just the titles of the top 5 results. Why is my Magento data out of sync? Why is my Shopify product not displaying? Why is Algolia out of sync with data? Why are my Shopify untracked products not retrieved? Or how is my Magento configuration affecting the number of indices? Who here thinks the best result is number 1? Is number 2? Number 3 maybe? Number 4? Number 5? No strong opinions, that's fair. Never send a human to do a machine's job. Here, our LLM identifies that the right answer is why is my Shopify product not displaying updated info on my site? And when you look at the content, it is very semantically similar. Why is this one on top? I think it's because out of sync was exactly in the title. So it looks like a very good keyword match. But when you look semantically at the situation of the user, it is actually not the best. This is the thing that the GenAI toolkit will identify. We are indeed returning the title and a summary. So here, when you look at the context that we retrieve, the second hit, why is my Shopify product not displaying, ends up being the response that we return. Why is Shopify product not displaying? Here are a few steps you should try. Occasionally, you might need this. To resolve, do that. Alternatively, try a full reindex, mate. What I like in this example is that if you look at the data that we retrieve, the data is just a crawler output from the Algolia crawler. We even still have \n everywhere in the text. But because we asked the LLM to provide a useful answer, it's going to take this and reformat it. And as a result, when we're replying to the user, we don't put the weird formatting in it. We just give them what they need to solve the situation and to avoid having to call support. I want to show you another use case that leverages the language model inner knowledge. Because right now, you might think, okay, it's powerful, it's nice, we do re-ranking, we do reformulation, but all of these summarizing and re-ranking you can do with simpler systems. You don't need a large language model for that. To me, the large language model really shines when you want to use inner knowledge as well. And this is a use case just like that. You're building a Netflix-like movies streaming website, and you want every movie to be introduced with a little description for the user. The problem is that your data has very few information. Here, this is the record for Home Alone 2. Okay, it has the titles in 15 languages, it has an image, it has the actors, but there's no description, there's no text, there's nothing I can show my user to entertain them. So we're gonna make, and this one is a bit hairy, bear with me, we're gonna make a prompt that has to present a movie using the context, else using inner knowledge in a specific format. So here's the instructions. Share one fun fact about this movie, actors or context. Use the context when possible, otherwise mention your incertitude. Say something like, this isn't in the provided context, but, or I didn't find anecdotes in the search results, but it's worth noting that. If you have no anecdote, don't invent one. Just reply something like, I have no fun fact for this movie, but go watch it. And this should be a sentence, a single sentence of at least 10 words, because that's the UX we want to build. Now a few examples. When the user inputs Pirates des Caraïbes into this system, we have the titles in French, so we match them. And the Algolia RAG will say, it's not in the provided context, but it's worth noting that Johnny Depp's portrayal of Captain Jack Sparrow was inspired by the rock legend Keith Richards. Did you know that? I didn't. I learned it when preparing this talk. I mean, didn't think Keith Richards was that scrummy, but hey. This is powerful because that information was not in the records, and yet we were able to provide the user valuable, useful entertainment in context on what they're looking at. If they ask for Home Alone 2, you saw the record. We don't have much information about it. But GPT-4, or if you're in Europe, Mistral Small 3 in our current deploy does. And as a result, we don't find anecdotes in the search results, but Home Alone 2 is filmed in New York in iconic locations such as the Plaza Hotel. What I like with the system is that it's doing its best, but it's not inventing. If you ask about Tenet by Nolan, we told it when it's not in the catalog, don't give us anecdotes. The user cannot watch the movie. Like, it's useless, this won't convert. And here indeed, I didn't find behind the scenes info, even if he has, but go watch it. And the last example, we have movies in the catalog, like the Lego Movie 2. But sometimes this movie is very niche, and so the users, the LLM won't know about it. It would risk inventing an anecdote. If we guard against this in our instructions, it will also tell, I didn't find behind the scenes info, but go watch it, keeping you in control and letting you build the experience that you want to build, not the one that it will think is the right one. With these few examples, I hope that I convince you GenAI can be useful. It's not just a fad. And with an audience of builders like this, maybe now you want a recipe. What does it take to bake this GenAI experience? Again, this cake has several layers. If what you're building is a GenAI experience, this is the cherry on top, the flower on top of the cake. You need to start with proper data. Once you have it, you need to set up your search relevance to retrieve relevant records. When you found the right records, you're not done. You need to extract useful chunks that you will pass to the LLM. And when this is done, you can generate an answer, but it doesn't mean every UX is the same. Writing the right prompts to provide a refined answer will ultimately make you have a great GenAI experience. So let's start from the bottom with the good data. For example, the record I showed you earlier is not good data. We don't have any textual information, there's no metadata, there is not much in this really, and that's why we need the LLM to invent to some extent. So what would good data look like? For something that is so textual heavy, so text generative, you want useful textual properties, title, description, even user reviews if you can bring them. Maybe a summary of the user reviews on Netflix would allow this experience to be a lot better. You also want clear categorical labels. Let's say that you have a category sport pants. This will be a lot more useful for an LLM to make sense of than if a category is called cat 22. The same with interlingual. If you have your own logic, your own naming in your company, it's great. But this is something that Mistral or GPT or any other LLM might have a hard time understanding. So if you say music ideal for Met Grunge region ice, it's not helpful compared to ideal for fans of grunge metal, fans of Iceland bands. This might pose a problem because you already optimize your search for your users for the current properties for what you search into. Maybe you need to duplicate some of the properties. Maybe you even need a separate index to be used for the RAG system to be optimized for retrieval for the LLM and still have your own search for consumers directly returning the right textual relevance. For all of these steps, I will go a bit quick and I will put links in the slides. At the end of the talk, you'll have the presentation slides. So here I would recommend that you look into Algolia Transform Your Data and the connectors library. We have a guide, Prepare Your Data for Indexing, that will show you a lot more about these considerations. And this, I find it amazing because when I joined Algolia in 2016, we would take your JSON and you would have to put it yourself. And now we have a whole family of connectors taking your data wherever it is. We also provide this transformation API so that you can pull your data from where it is and do a little transformation to add those textual properties I told you about. Maybe even pulling your own ontology from your company so that you turn category 22 into sports pants. Now you have good data, you can look at your user query and try to understand the user intent. Intent is also an overloaded word, but to me it's what do they mean with this query? What is the meaning behind it? Sometimes a word can be ambiguous. What are they trying to communicate here? A big area of this in search is query understanding. There are many tools you can use to analyze a query before looking at the results that you could return. A basic level is, can you identify keywords and stop words? Do you know the language that the user is speaking in? Can you remove the stop words from this language? And this language only. If in English, the is a stop word, when in French I type thé, I want some thé. Give me the thé. You should not treat it as a stop word too. So it's very language specific. The same for the plurals. There are many cases where foot and feet should be treated the same. You should not penalize that query if the data doesn't have the same than the user input. Maybe you want to do further natural language processing. On some use cases, you would want to do a lot of query expansion before getting there. And indeed, query expansions, they are low-hanging fruits that you can do. One of them is to use synonyms. Is trousers really different from pants in your use case? Maybe you want to apply some rules. Should I treat a keyword that is also a facet value differently? For this, check out our guides, Handling Natural Language and Adding Synonyms as a place to get started. We also have dynamic synonym suggestion that will learn from your users to recommend new synonyms, keeping your experience up to date with the latest lingo. And on user understanding, it would be sad not to mention query categorization, because when we build such broad systems, we want to answer users where they come from. And that means sometimes routing them to the blog, or to the products, or to the FAQ, or to the forum, and understanding what kind of content this query is about. Is there something else to this demand? If you use the query categorization, in Algolia you can predict relevant catalog filters. When I say, do you know a good club for putting? I'm talking about sports. Whereas if I say, do you know a good club for techno? I'm probably talking about nightlife. And you should treat club differently in those two cases. If you use the Algolia query cat feature, you will get for any query predictions with scores, and you can use those scores. Do you want to only add the ones you're very certain with? Do you want to use optional filters to boost the ones that we detect? Up to your implementation, but I think these are a good place to start from. Again, check out QueryCat on our docs and the Query Understanding 101 blog post. With these, you now have a better idea what your user means with the query. You can start giving them relevant results. But how do you retrieve them? What are the right settings to find relevant results? I don't know about your catalog sizes. Mine looks like the Bibliothèque Nationale de France collection. There are many thousands, millions of items. So you need a big cursor into it. Here, it will depend what your backend for search. If you're using Algolia as a classic search, you will have keyword relevance. If you have access to neural search, you have a vector retrieval system that does semantic search alongside the classic. If you're using Elasticsearch, by default, you will have a traditional search with keyword and a score. They also have vector indices. If you're using a vector database like Pinecone, you only have vectors to retrieve from. Here at Algolia, we support different approaches. You can have only classic relevance, you can use neural search, you can use it as a second layer if the first one gives no result, or you can blend them together. For the rest of this talk, I will talk about the classic relevance, both because this is the most accessible, any of you could use it tonight at Algolia and try what I'm talking about, but also because many other systems will have this same approach. So let me show you a few classic relevance considerations, and when it exists, the Algolia parameter in green that you can control with this. First of all, your basic search settings are going to be important. If you saw the example of the podcast, we are searching in the episode title and the description, but we shouldn't search in the URL or in the ratings or in the comments. So what attributes you search into, in Algolia we call it searchable attributes, is a key parameter. While you're here, you should also configure typo tolerance. Is someone asking for Rihanna the same thing as someone asking for Rihanna with two N's? Should you care about it? Most of the time, yes, but you want to be typo tolerant. There's exceptions. If you do user-generated content, when you're Twitter or X, you have to handle the fact that people will create a Rihanna with 3N account. And if you return exact match first, you will give the users to the typo squatters. So depending on what kind of content you have, is it user-generated or not, typo tolerance considerations will change. There's also the question of how do you match the words? Do you want to keep a partial match? If you're speaking German, it's a no-brainer. The words agglutinate, so a partial match is better than none. In French, sometimes a partial match is good too. When I'm typing chocolatine and there's only pain au chocolat, I think it's actually good to return the pain au chocolat as well. Once you're done with the search settings, you should look at the ranking formula. This is the way that we configure the ranking for an Algolia search index. And by default, the ranking formula will use criteria one after the other to decide if a result is relevant. Those criteria are right for many experiences, but maybe not for yours. Do you care about the distance between the words? If there is a first support entry that has the two words match close, out of sync, and there is a next one that matches more keywords, for example, Shopify, but the words are separated, is it a better match? In the case of support, I think yes. So in my case, I would remove distance or put it lower. The same for the number and the order of attributes you match. Do you prefer a result that matches 3 words in the title or a result that matches 5 words across different properties? It will depend on your use case. There are a few other considerations to ponder when talking about classic relevance. Is your use case affected by geolocation? I was talking with customers who want to build for their website a GenAI experience that is working for their e-commerce website online, but also bringing people to the brick and mortar local shops. So they want to show products that are available locally first. For them, geolocation is a big driver of search performance. Maybe also you have a more complex situation and you need to define rules, either manual rules when someone type iPhone, show them Samsung too, or maybe automatic rules, dynamic rules, such as if I type cocktail party dress and dress is a category, do the filter category dress for me and just search for cocktail party within these. Once you configure a relevance, there is still the question of the length of the results. Because you're not showing those results to a user, you are passing them to a language model to accomplish your instructions. How many documents should you give them? You can give fewer documents. That's nice, it's less noise, it's also cheaper. Have you seen the price of tokens these days? But you have less context. You get higher precision results. But with the lower recall, maybe the LLM will miss something. So, of course, with any system, with a question that is how many, as an engineer, I answer more. I always bring more data. For the players of Warhammer in the room, data is how the goblins called the machine guns. And they're like, oh yes, more machine guns, always better. For those who haven't played Warhammer, just remember, data is the thing you need more of. But the thing is, bringing more results will also bring more noise. And as I mentioned, will cost bigger. In the support example, we gave only 5 tickets. If we looked at 20 entries, maybe we have more chances to answer. Do you think it would help if we look at 50 entries? At 1,000 entries? Give the whole FAQ to the LLM? It probably won't help. What's the point of search anymore? We want search to refine, and then the language model to do its magic on top. Because otherwise, you give it everything, you have a very high recall, but a very low precision, as in the beginning examples. A last question on relevant document is, do you deduplicate the results? If you're passing a set of 4 clothing items with variants of colors, do you give those 4 hits to the LLM, or do you give the 16 different variants? For e-commerce products, I think this would be a waste of tokens. All those variants are visual alternatives, so they will mostly add noise if your instructions is to summarize for who it would be a good fit. I'm not sure adding 5 variants in each color helps. But if what you're doing is content, and you're looking at FAQ articles or a blog post, here this is JSON of a blog post entry, where we have title, content, and each section is broken down. If you do this on Algolia search by default, we tell you to set it with distinct on the section, so that when someone searches, you don't show them 5 results for the blog post, you show them 1, the most relevant one. But if you are the LLM trying to answer the support question, you need to see them all. You want all of those data, because each chunk could be the answer. When you split it this way, you have non-overlapping chunks, and the answer could be in any record. It could even be across several, maybe it's split in between. So you need the LLM to see them. Which means maybe your chunking strategy will not be the same one. When you split blog posts by parts, it's nice, but maybe an answer is in between. So you can look at different chunking strategies. I won't dive too deep into this. There are great blog posts about it, as you'll see in Jagadish and Ganesh Understanding Chunking Algorithms post on Medium. For example, this one is fixed size chunking. You just split on space, and you do fixed chunks for each. No overlap. That's nice. There's no data waste, but maybe you miss the answer. So you can do the same with some overlap. Here we're making 150 characters chunks with 50 overlap. So there's a third of repetition. You make sure that the answer is always in there. But you could do smarter strategies. You could do chunking based on the sentence. These are imports from LangChain, by the way, so very easy to spin in a Python code base. Here you would split on the sentence. What I like is that it splits first on paragraphs, then on new lines, then on dots, and finally on sentences separated with spaces. So you can really prioritize what you like. There is even a last one in his blog post that I find crazy. Sliding window, sure, But have you tried Markdown chunking, where you split your text by headers so that you have the title, subtitles, block quotes in separated chunks? Very semantic, very nice. When you're done with this, you now have relevant documents, and your library looks a lot more organized. You know what records would best answer the user query. But what do you pass to the LLM? The question of the augmentation, the A in RAG, is what would be the right context? What data do you pass to the language model so that they can answer your instructions and finish the job where you left it? I will show you a last use case to illustrate that. And this is the CIA Word Factbook. The American well-known agency has a website where they share facts, or at least their own data, about 265 countries and territories in the world. So if you look at Italy, you will see photos, you will see maps, you will see metadata about the land, the climate, the terrain, the economy, the energy, the communications, like hundreds of different properties. I found a nice project that scrapes that every week and puts them into a GitHub. So you can download the JSON every week and have structured data from the CIA. And you're starting to know me. When I have structured data on a GenAI system, I start speaking with it. So here, I'm asking the question, in Vietnam, how many phone lines total mobile and landlines? Show me your work if you compute anything. And in the answer, Vietnam has 2,391,000,000 fixed and 136.412 million mobile. I need to add those numbers together, so Vietnam has 139 million phone lines. If you scroll down the JSON, down below environment, energy, communications, line 213, we actually had this information in the document. And the numbers are actual, 2.391 plus 137.4, that is indeed 139 million lines. And here you can see the power, the strength of such a system. You have solid data you can trust, the numbers are exact to the second decimal, and yet you can ask open-ended questions and have open-ended answers. And because we shipped a conversation feature recently, thank you again, Guillaume, this is really nice, we can continue the conversation with the Vietnam use case. After I ask how many phone lines, I'm gonna ask, okay, so what's the share of mobile in percentage? We use the same data, and the answer now is approximately 98%. Now you might be wondering, why do I care about the mobiles in Vietnam? You would if you were doing advertising there. Because when I ask the next question, I have 2 million marketing campaign for Vietnam. I am a telecom operator. How much should I keep for the landline-focused communications? Using the data we retrieved, using the computation the LLM did before, we get the answer. There's a low penetration of fixed lines in Vietnam, only 2 per 100 inhabitants. It would be prudent to use a minimal portion of your budget for the landlines. Probably those won't buy much. This is something you could build tonight using our system. The CIA Factbook data is open data. The GenAI toolkit exists in production. And this is using here in Europe the Mistral open source language models. But now you understand the problem of what attributes to pass. We have a huge data record. Those are 30 kilobytes of JSON. Do you pass the whole thing to the language model? I mean, you could. If you don't set attributes to retrieve, by default, we will pass the whole record. But this will be probably hard for the LLM to extract. So it depends on your use case. But if you're able to say what properties should be used for a given instructions, maybe for user support, you will have different attributes than for FAQ entries, than for shopping assistants. But that will help the LLM focus on the task at hand instead of doing parsing when it should focus on how to speak to your customers. So it depends on the use case. It also depends on the cost and the capabilities of your system. If you're using the latest and greatest, have you seen Claude 3.7? Surely they can parse JSON. No, they're also more expensive. So do you want to do a little more work to pay less per token? It could be a good idea. Finally, you can also control what are the right extracts. I just talked to you about attributes to retrieve, to configure which attributes you use as context. But besides which, you can also control how much of each attribute you display. With attributes to snippet, you will keep only a number of words that match the user query from this attribute. So if you have medium descriptions but very long content, you might want to set the content to only snippet the last 80 words that match your query. Also consider the format. What I showed you right now, we're passing JSON directly to the LLM. That works great because they can see the keys and the values. But maybe your use case only cares about the text. If you are doing support, maybe you want to pass just the body and only the body, not the whole structure. Maybe you want to apply a custom transform, like I showed you earlier with the transformation API, to only keep the right thing for your current task. So you have data. You're retrieving the right results. You are extracting what is important to them. There's one last thing, to give the user a useful answer. You want the GenAI experience to be satisfying. You want users to come back and to ask for it again the next time they come. So what makes your GenAI system, your generated answer, useful? There's different ways to approach it, but I would say that a useful experience is an experience that customers prefer over the baseline, over the previous default. If you cannot show that this is better than before, then it's nice, but it's not actually useful. So are they more efficient now? Can they achieve bigger goals or go faster at their tasks? If you build great UX, they should be able to achieve more with your system than with the previous search interface that they had. So here are a few last tips on how to make the answer more useful. On this CIA example, when I ask in Vietnam how many people have phones, and it tells me 137.412 million as of 2022, I'm not sure what to do with it. We're in 25. Is the data a bit old? Is the info wrong? Did it misunderstand my question? With just the response, I am left in the dark. When you compare that with the experience that my colleague Guillaume built, when you ask a query to Huberman, and I tried this yesterday evening, I'm preparing a talk for an audience of search experts, help me not be stressed. The answer by Huberman was a bit surprising. To help reduce stress before your talk, consider taking 100 to 200 milligrams of L-theanine just before. This can enhance your transition to a calmer state. I was looking for meditation or mindfulness tips, not drugs. But fair. Okay, is that even something Huberman would say? Or does it come from a LLM hallucination? Here, showing results and what data records have been retrieved before generating the answer will help reassure your user. They will be in control. They will be able to double-check. Here, indeed, Huberman talks about L-theanine. But if you look closely, it says it should help you take 100 milligrams or 200, 30 minutes or 60 before sleep. So it's not something to do before a talk. And this is a case where GPT-4o, with all of its powerfulness, actually was wrong understanding what Huberman tells. I am happy I didn't follow this tip just before the talk. Otherwise, I would have been sleepy instead of enthusiastic. So please highlight the results to showcase why they are relevant. You can use the Algolia highlighting. When we search in the dashboard, we show you why this is a good hit. It shows you why a record is relevant. And at the very least, use keyword highlighting to highlight which attributes are relevant. But you could go further. And I will show you an example that I lifted from a previous job by Dustin Coates, who built this semantic answering solution with Claire and I on Algolia Answers. And here, when you ask, when do babies start to learn? We were able to highlight before we are born as the right part of the answer that matches your question. And this is using a question answering Hugging Face pipeline, which can be quite nice on some use case. So you're done. You now have a useful answer. You built a great GenAI system. Are you finished? There's just a last thing. How do you know if it performs? You want to know if your GenAI brings value. Otherwise, it's just a fun project. But how do you know if a feature is valuable? You ask your users or you observe them. First, you look at your search analytics. Do you see a bigger volume? Is there any usage? You can look at the search metrics, but they're a bit irrelevant. The click-through rate, the conversions, well, of course, the item have a role in this. But if your answer is bad, it's not the records that was wrong. So the relevance metrics might tell you a part of the story. Maybe average time on the page is a better predictor. If people are using your system, it's a good sign. The bounce rate also. Are they staying here or are they leaving as much as before? But all of these are quantitative. And quantitative approaches have big limits, like you'll see in Elizabeth's next talk. So I would let you think about your use case. Those are only examples. And with this, let me summarize search relevance in the GenAI age, or how to bake a delicious rag cake. You need to understand your users with various query understanding and natural language processing techniques. You want to structure your data and to configure the relevance according to the user needs by chunking, using the right attributes, defining your ranking formula, using typo tolerance if it makes sense for your use case, considering geolocation and all of those criteria. Then extract from your records the right chunks so that the LLM can accomplish the task you want them to do. You want, finally, to design your generative experience to make it useful and efficient so that it helps your user. It should be an ally to your user, not a toy that you drop on his path or their path as they're achieving their goal. If you do this, your users will come back for a second serving. If you cook it right, you'll understand your users' desires. You will retrieve healthy data for them. You will give them delightful answers, and they'll leave hungry for more. Thank you for watching Search Relevance in the GenAI age. We have time for questions, but I want to share with you 3 links. This is the slides, so all the links I showed, you can find them there. On the left, you have a QR code to get free access to the Algolia GenAI toolkit. Sign up there, and we'll hook you up. And if you're not convinced yet, try Podragster. The right URL will bring you to the demo, and you can play with it as much as you like.
Does anyone have questions for Paul-Louis?
Yeah, have you considered using the GenAI to modify the query parameters to then maybe like play with the recall and precision knobs?
That's a very good question. We haven't showed it, but yes. In the conversation mode, at every turn of the conversation, we reformulate your query. So if I show you the examples where we were talking about Vietnam, when I do the first query here that says, how many phone lines total? Then a second query, so what's the share? And the third query, how much of the budget should I keep? We're rephrasing the search query at each step here to keep the Vietnam record in memory. There was an example when searching for movies where you ask for recommendations of movies about musicians. Then you ask, compare the first 2. And this we would rephrase as a new search to find back the first 2. Now we need to expose it and to give you controls over it so that you can use the reformulated query or not, depending on your use case.
So is it checking if there's an answer in the first thing and then changing it?
Yes, I think so. What we're doing right now is one more round of LLM interaction, asking it, given this history, what is the current user search query? And so it's refining it, removing stop words a bit as well, but also bringing back the previous interactions in context to give a current query based on the 3 requests.